I am Anil Kumar. Welcome to my series on solving quadratic equations. I am Anil Kumar. Welcome to my series on quadratic relations. In this particular video, we'll discuss how to solve quadratic equations. We'll first understand the meaning of solving quadratic equations. Then we'll move on to understand the differences between zeros, roots, and x-intercepts. Then we'll solve some basic quadratic equations. We'll solve from the factored form. We'll factor and solve. We'll solve from vertex form. We'll apply quadratic formula and then provide solutions to required decimal places. And then we'll take up an application example. Let's begin with understanding the quadratic equation itself. Quadratic equation represents a polynomial of degree 2. The graph of a quadratic function is a parabola. General form of quadratic equation is ax squared plus bx plus c, where a, b, and c are belonging to real numbers. So let's connect these two statements. Polynomial of degree 2 and this particular formula where you have x squared. So ax squared plus bx plus c is a form of a polynomial. The highest power here is 2 and we say it's degree 2, right? To solve equation is to find the value of x which satisfies the equation ax squared plus bx plus c equals to 0. So we have now converted this equation, written it as 0. So to solve an equation really means to find the value of x which will make the value of the whole equation as 0. So you can say to solve means to find zeros of an equation. So these values of x are called the zeros or roots of equations. The real roots are represented by x-intercept on the graph. So we have used the term real roots related to x-intercepts. So there could be imaginary roots also. So we could have imaginary roots also. So many times when you have a quadratic function, you are saying there are no roots. We are actually meaning to say no real roots, right? For example, this particular function has no roots, but it has two, we can say one set of or two imaginary roots. So we are going to learn this concept soon in next grade. But you should keep in mind, okay? Now, here is a question for you, which is what is the difference between zeros, roots, and x-intercepts of a polynomial? So think about it, and we'll actually answer this question in our video. So now we'll take up what is the difference between zeros, roots, and x-intercepts. To explain the concept, I've taken three situations. So these are the parabolas which represent the quadratic function or quadratic relation. And as you can see, in the very first case, we have two roots, the two x-intercepts. In the second case, we have only one x-intercept or one root. But here, we do not see any x-intercept. But do we have roots or solutions of this equation? Every equation has a solution. Now that solution could be real or imaginary set of numbers, right? Okay. So in short, let me say that in the first case, we have two x-intercepts, two real distinct roots, right? And two linear zeros. So the zeros are also at these x-intercepts. However, their nature is linear. It's kind of a straight line. In the second case, we have one x-intercept. Both the roots have now at one point. So we have double real roots. So it is like an expression which could be written as, let me write down the expression which could represent this information, which is, we could write this as x plus 2 whole square. So in this case, when you equate it to 0, you'll get two roots at minus 2. In the first case, you could write an expression as x plus 2 times x minus 2 to represent both these values. Correct? So let me write a value a, which is 1 in this case, but could be any value sometimes. But we are focusing on this part. In the third case, I cannot easily write down the equation since we do not have the roots. Well, we could use the vertex form and then write its equation. So, what you note here is that we have got two roots, two solutions, but they are not distinct. They are one on top of the other. So, important thing which I want to highlight here is that there is a double root, right? And second is there's one quadratic zero. So with zero, we're trying to define behavior of curve at the x-intercept. So in this case, what we are also saying is zero indicates behavior of curve at the root. Is that clear to you? Perfect. So zeros definitely is a solution also, and it also gives you an added information, and that is behavior of the curve at this point. So here we are saying linear zero. So let me highlight the term linear zero means going like a straight line, and in this case it is turning, and that is what we mean when we say quadratic zero. Is that clear to you? Perfect. So it's turning at this point is a quadratic zero. So I hope with this you get an idea. In the third case, there are no x-intercepts. It doesn't mean that the equation doesn't have solution. It has two imaginary roots, which you're going to learn in the next grade. So no real roots. That's kind of important. And it has two imaginary zeros. Zeros are actually the solution. Now let's try to see how to solve some basic equations based on quadratic equations. So the very first one here is y equals to x squared minus 1. Now when I say solve the equation, solve really means we need to equate y equals to 0. So that means to solve. So we have to solve x squared minus 1 equals to 0. That is what it means. So even if I write y equals to something, you have to equate the whole equation to 0. So when y is 0, what is the solution? So the x value, which makes it 0, will be, we could rearrange and write it like this. So x will be square root of 1. Whenever you do square root, you have to write plus and minus. So we get two solutions, which are plus and minus 1. So that is how you're going to solve it. Is that clear to you? Perfect. Now, let's take up the next example here, which is y equals 2. So we'll write this as y equals to 5t squared minus 20, where we are saying t is greater than 0. So in this case, the answer should be written positive t only, not the negative value. So we'll again equate it to 0 and then try to find the solution. So we'll solve it in a way we did earlier. However, there's one difference. And the difference is that we have to take positive values, correct? So you could rearrange and get an expression on the right side as 4. So t will be equals to square root of 4. So plus and minus actually gives you two values, which is plus 2 and minus 2. However, we are saying that t is greater than 0. So the only solution is t equals to 2. We'll ignore the other one, which is not a part of solution. So when you write down the answer in this case, you say t equals to plus 2. Is that clear to you? Perfect. Now let's take the next example, which is y equals to n squared plus 4. So we could have any variable here, not necessarily x. So equating y to 0, we get 0 equals to n squared plus 4, and that gives you n squared equals to minus 4. Now, square can never be negative, so we have no real solution. So an equation can have zero solutions, no real solutions, or one solution or two solutions. So in this case, we're actually working in the set of real numbers, so it has no real solution. So now let's take the next example where we are going to find the solution based on the factored form given to us. The very first example is x times 2x minus 1 equals to 0. You can actually pause the video and answer this question. Now here, when we say that product of two factors is 0, that means we could equate x equals to 0. That gives you one solution, and 2x minus 1 equals to 0. So that gives you 2x equals to 1 and x equals to half. So we can now write down the answer, which is x equals to 0 and x equals to half. Is that clear to you? Let's try to solve the next question. We are given 2x minus 3 times x plus 1 equals to 0. That means that 2x minus 3 equals to 0 or x plus 1 equals to 0, right? So solving, we get 2x equals to 3, x equals to 3 over 2 as one of the solutions. Here we get x equals to minus 1 as the other solution. Perfect. So we have two solutions. We can write down our answer as x equals to minus 1 and 3 by 2. Perfect. The next example, we have four parts in this. This time we have to factor and then solve. So let's begin with the very first one, which is 2x squared minus 50x equals to 0. We can do the group factoring. So we get 2x and then we get x minus 25 equals to 0. Now each factor can be equated to 0. So this gives you x equals to 0. The other factor, x minus 25 equals to 0, gives you x equals to 25. And therefore, we have two answers in this case, which is x equals to 0 and 25. Clear? Let's take part B now. So in part B, we have 100x squared minus 9 equals to 0. Now this could be factored as 10x plus 3 times 10x minus 3. So difference of squares will be used to factor this. So 10x plus 3 equals to 0 could be one way of getting the solution. 10x minus 3 equals to 0 could be the other way, right? So there are two factors, equate them to 0. So we get 10x equals to minus 3 or x equals to minus 3 by 10. Here we get 10x equals to plus 3, x equals to 3 by 10. And so we can write down our answer as equal to, you can also write in decimals if you want to, that is plus and minus, you could write 0.3. Is that clear to you? Now let's take the next question, which is solve from the vertex form. Solve and write the exact answer. A, 2 times x minus 1 whole square minus 8 equals to 0, and 1 over 3 x plus 5 square minus 5 equals to 0. You can always pause the video, answer the question, and then look into my suggestions. So the first one here is 2 times x minus 1 whole square minus 8 equals to 0. Let's rearrange. We get 2 times x minus 1 whole square, taking 8 to the right side. Now we will divide by 2 on both the sides. So we get 8 over 2, which is 4 on the right side with x minus 1 whole square. So x minus 1 can be written as square root of 4 with plus and minus sign. So that gives you two possible answers, plus 2 and minus 2. So we get x equals to either 2 plus 1 or we get x equals to minus 2 plus 1. So x is equal to 3 or x is equal to minus 1. So these are the two solutions for the first equation. Now let's take the next equation given in vertex form. So here we have 1 over 3 x plus 5 whole square minus 5 equals to 0. Take 5 to the right hand side. So we get 1 over 3 x plus 5 whole square equals to 5. Now multiply by 3 on both the sides. You get x plus 5 whole square equals to 5 times 3, which is 15. We can now do the square root. So we get x plus 5 equals to plus minus 15 square root. correct? So x is equal to minus 5 plus minus 15 square root. So that becomes the solution for the second equation in the exact form. Clear? The next example is based on quadratic formula. So let me first share with you the formula itself and then we'll write down the answer. So if the equation is given to you in the form of ax squared plus bx plus c equals to 0, in that case x is equal to minus b plus minus square root of b squared minus 4ac over 2a, where a is coefficient of x squared, b is coefficient of x, and c is the constant. Now in our case, we are given the equation which is x squared minus 5x plus 3 equals to 0. So clearly, the value of a is equal to 1, b is minus 5, and c is equals to 3. Applying the formula, we get x equals to minus of b, that means minus of minus 5, right? Plus minus square root of minus 5 squared minus 4 times a and c. So a is 1 in this case and c is 3. So substitute these values in the formula and find the answer. So we get 5 plus minus, that is 25, and this is minus 12 over 2. So that gives you 5 plus minus square root of 13 divided by 2 as your answer. Is that clear to you? So that is how we'll find the solution. Now let's look into the next question, which is 2x squared plus 3x minus 1 equals to 0. So the question here is 2x squared plus 3x minus 1 equals to 0. So x is equal to minus of b. So I'm not writing a, b, c now. Straight away, we could write this as minus 3, right? Minus of 3 plus minus square root of b squared, so which is 3 squared, minus 4 times a, in this case is minus 1, and c is 2, divided by 2 times a, which is 2 times 2. So that gives you minus 3 plus minus square root of 9, that becomes plus 8, right? Minus 1 times minus 4 is positive. So we get this divided by 4. So we get our answer as minus 3 plus minus square root of 17 divided by 4. Do you see that? So these are the exact forms of our answers. Sometimes they will say, well, now in this case they're saying correct to 10th place. So let's now round the answers to the 10th place and write down our answers. Correct? So we have 5 plus square root 13, and then we are going to divide this by 2 to get our answer in decimals. So one of these answers when we do plus is, so we'll do 5 plus square root 13 divided by 2, that gives us 4.3 as a 10th place. The other one is 5 minus square root 13 divided by 2, and let's calculate this. 5 minus square root 13 and dividing by 2 in decimals, we get a value 0.697, which could be written as 0.7. Correct? Here also we'll do the same calculation, but with the values of minus 3 plus square root 17 over 4. So we have minus of 3 plus square root of 17, and we're dividing this by 4 to get the answer in decimals as equal to 0.28, rounded to 10th is 0.3. Then we have minus 3 minus square root of 17 over 4. So we have minus 3 minus square root of 17 divided by 4 gives you the answer in decimals as minus 1.78. So I'm rounding it to 8, correct? So those are the answers. So let me write down the answers now to decimal places for both of them, it is 4.3 and 0.7, and for the other one it is 0.3 and minus 1.8. Is that clear to you? So that becomes the answer in 10th place. Now let us take the next example, which is we'll work with simultaneous equations. It says determine value of x that satisfies the equation x squared plus x minus 4 when y equals to 26. So we are given two equations here. Let me rewrite the two equations as y equals to x squared plus x minus 4 and y equals to 26. So I should write here y equals to. Is that okay? Now these are the two equations given to us. We want their solution. That means both y values should be same. So we could rewrite this as 26 equals to x squared plus x minus 4. So rearrange by taking 26 to the other side. So we get x squared plus x minus 4 minus 26. And that gives you 0 equals to x squared plus x minus 30. You could actually factor this equation. We're looking for sum and product. Minus 30, 6 times 5, right? So it gives you x plus 6x minus 5x minus 30, which could be factored and written in the factored form. You could have written directly also the factored form, which is, now we'll go the long way. We can take x common, x minus 6, and here minus 5 is common. We get plus 6 and x plus 6. So when you factor this, you get the terms x plus 6 is common factor times x minus 5. Now for this to be 0, x plus 6 equals to 0 or x minus 5 equals to 0. For x plus 6 equals to 0, we get x equals to minus 6, and here we get x equals to 5 as our answer. So the solution for this simultaneous equation is x equals to minus 6 or plus 5. Clear? So that is how we are going to solve this. Let's take the next example now, which is an application question. It says, the height of a ball in meters after t seconds when dropped from a cliff is given by h of t equals to minus 5t squared minus 5t plus 230. How long will it take the ball to be 130 meters from the cliff? So let's try to understand the question, which says that the height h of t is equal to minus 5t squared minus 5t plus 230. And here t should be greater than equal to 0. When t equals to 0, that is height in the beginning is basically equals to 230. Okay? So when you are throwing the ball from the cliff, let's say that's the cliff, right? So the ball is being dropped from here. So that is the initial position of the ball. So it says the height of the ball in meters after t seconds when dropped from the cliff is given by this particular equation. How long will it take the ball to be 130 meters from the cliff? So we want to find the time when it is. This distance is 130 meters. So at t equals to 0, it is right there. So we want to find this time. Is that clear to you? That is the time which is required. So at this time, the distance traveled is 130. So we will equate this height to 130 here. Correct? So it is 130 is the distance from the cliff. So remember, so height of the ball in meters after t seconds when dropped from the cliff is what? So at this time, the height initially is 230, right? When t is 0. Now, from the cliff 130 means we have to find from the ground what is the height. Is that clear to you? So, from the ground it is 100 meters. Perfect. So in this particular case, the height is going to be 100 meters. So we'll write here 100 equals to minus 5t square minus 5t plus 230. Does make sense to you? Correct? So it says once again, height of the ball in meters after t seconds when dropped from the cliff is given by this expression. So this height is being measured from the ground. You get the idea. When t was 0, the height was 230. It makes sense. It was very high. Now, over time, the height is decreasing. When it hits the ground, the height will be 0. Now the question is, how long will it take the ball to be 130 meters from the cliff? So from the cliff, if it is 130 meters, from the ground it is 100 meters. And that is why we are writing height as 100 meters. And then we are going to solve this equation. Perfect. So we can write this as 0 equals to minus 5t square minus 5t plus 230 minus 100. Perfect. So that is how we are going to solve it. Now, I normally would like to take this as positive. So we'll write this as 5t square plus 5t. And we'll change the sign later. So minus, when you take away on this side, it is 130 positive. But when you take it to the other side, it will be 130 negative. Now we can use the quadratic formula to factor. Right. You could also take 5 common and write this as t square plus 5 is taken common. Dividing this by 5, we get 5 times 2 as 10 and 30 is 26 equals to 0. Is that clear to you? Now, so 5 times 2 is 10, 30 is 5 times 6, 26. Now, if you try to factor this, you cannot really factor with integer numbers. So we'll use a quadratic formula to find t, and using the formula which we used in the previous example, we can say t is equals to minus 1 plus minus square root of b square minus 4ac. Because this is negative, it becomes 4 times 26 divided by 2. Clear? So that becomes the answer. So let us now calculate the value. We have within the square root 1 plus 4 times 26, that is 105, and square root of 105 is equal to 10.24, or let's write square root of 105 as equal to minus 1 plus minus 10.25, let's say, divided by 2. Since we are looking for a positive value, we'll take 10.25 minus 1 and then divide it by 2 to get our answer, which in decimals is 4.62. Rounding it to the question doesn't signify that, so we'll leave it to 3 significant figures. So by default, that's a good option. So the answer here is it will take 4.62 seconds. Clear? So that is how we are going to answer this particular question. I hope the steps are absolutely clear. In this particular set of questions, we have answered many questions related to quadratic equations. We have learned how to solve quadratic equations. We learned the difference between zeros, roots, and x-intercepts, and we have seen how to solve equations when given in factored form, or how to factor and solve, and how to use the vertex form to find the solution. Also, we had an application question to use the quadratic formula to find the solution. I hope that makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.